All right, now we get into kind of the fun of graphing these. Now that we see what it looks like, we understand where the points on the curves come from. It comes from the unit circle. Let's get into some details here. When you have a sine and cosine function, they have a basic form. Y equals a times the sine of bx. Or it could be a cosine function. Y equals a times the cosine of bx. I tend to put parentheses around what we're taking the sine of. It's of that whole b times x. You won't always see parentheses there, so just heads up on that one. So let's put a couple definitions that we're going to keep referring back to. Our amplitude is the absolute value of that a. So if there's any number in front of your sine or cosine function, that a value will give us the amplitude. Remember, amplitude is the maximum or minimum value. It helps us graph these. And if there's not a number there, then our a value would be a 1. The period uses the b value. So if you are multiplying any numbers by your x, that's going to be your b. And so we find the period by doing 2 pi divided by b. All right, so part A, what is the amplitude and period of the function f of x equals 3 times the cosine of x? So first thing we're going to do is we're going to identify the a and the b value. So our a value of our function is the number multiplied out in front of cosine of x, so our a value is 3. And our b value is any number that might be multiplied directly with the x, which in this case is just a 1. So knowing the a and the b gets us the amplitude and period. So the amplitude is the absolute value of a, which is 3, and the period is 2 pi over b, so 2 pi over our b is 1, so our period is 2 pi. Remember, what that period means is that we will have one cycle of our function within 2 pi. Why don't we graph this? This is the fun part. So when we graph this, we tend to just kind of start at the, our origin, and then we extend out along the x-axis. Those are going to be our positive x values. Because our amplitude is 3, we are going to have our graph go up to a 3, 1, 2, 3, and down to a negative 3, 1, 2, 3, negative 3. It is helpful to draw in just some guiding horizontal lines at that 3 and that negative 3. So what that is going to look like is, I'm just going to draw myself some guides. The entire sine or cosine curve, this is a cosine function, is going to fit within those two horizontal lines. All right, now we have a period of 2 pi. So we're going to go back to our x-axis, and I'm going to say, here's 2 pi. I'm going to divide this up. Halfway between 0 and 2 pi is pi. And maybe I'll divide it up one more time. Halfway between 0 and pi is pi over 2. And then right here is a 3 pi over 2. So here's the pattern of your cosine function. The cosine function has the y-intercept at the maximum value. So I know I'm going to cross the y-intercept up there at 3. Because the period is 2 pi, at 2 pi right here, I'm going to be back to that same spot because then it's going to start repeating itself. So I'm going to plot another point up here at that 3. Now we're going to do some halfway points. Halfway between here and here, between 0 and 2 pi is pi, and that's where, so here's that halfway point, that's where you're going to hit your lowest, the minimum. So I know our function is going to hit a point right there. Now, halfway between 0 and pi, which is pi over 2, it's going to hit the x-axis. So I know we're going to hit right there. and then halfway between pi and 2 pi, I'm not going to connect with a straight line, but you can kind of see it's going to hit the x-axis right there also. And then we can draw in our cosine. It is a curve. Don't draw in like zigzags. It's a curve. It hits that, comes down. Oops, I missed that one. Let me try that again. Curve, hits that, hits that, hits that. There's our cosine curve, something like that. We could continue and get another curve if we wanted, but we got one cycle to fit from 0 to 2 pi because our period is 2 pi, so we get a full cycle to fit in there. All right, part B. What is the amplitude and period of f of x equals a negative sine of 2x? So let's identify some information. We want to identify our a value is a negative 1, and our b value is 2. Now, just a reminder, if you have a negative out in front of your function, that's going to be a reflection. So maybe we'll just make a little note that this is going to have a reflection. But let's identify the amplitude and period. That's what we're being asked to do, and then we're just going to graph it because that's fun. The amplitude is the absolute value of your a value. So our amplitude is 1. We took the absolute value of the negative 1. The period is 2 pi over b. So 2 pi divided by our b value is 2. We'll simplify that. Our period is pi. So what that means is that's going to be a horizontal compression. If we look at our cosine function above, we fit one cycle into 2 pi. If our period is pi, that means from here to here, we would fit in that whole cosine curve. So it's going to be more squished. It will be horizontally compressed. So why don't we do a quick little sketch of this? Let's get our axes. Our amplitude is 1, so that means the highest will go as 1, the lowest will go as a negative 1. You can draw in those horizontal guides. All right, next we're going to plot the period. Our period is pi, so maybe we'll put pi right here. I'm going to go ahead and throw in 2 pi as well. Halfway between 0 and pi is pi over 2. Halfway between pi and 2 pi is 3 pi over 2. And let's plot some points. So your sine function will go through the origin. So the y-intercept is at the origin every time. Now, normally we would go up. Well, actually, let's not talk about that yet. Our period is pi. So I know that we are going to be back on the x-axis at pi because that's when it starts repeating itself. So we're going to fit one full cycle between 0 and pi. Normally a sine function would go up, come down, and go back to center. Because of the reflection, it's actually going to go down and then up. I keep getting ahead of myself. Geez, let's plot some more points. So when you do your sine function, you've got basically the end points of your period. Now do your halfway points. Halfway between those, you're going to be back on the x-axis. Halfway between these is when you're going to hit your amplitude spots. But because we're going down first, halfway between those, I'm going to estimate right there. And halfway between pi over 2 and pi, we're going to estimate right there. And now we can draw our curve. Our cycle is going to go down, up, and back. That's a reflected sine curve. We could repeat that. Why don't we go ahead and repeat? From pi to 2 pi, we'll fit in another cycle. Halfway between those, we hit the axis again, and then do your halfway points. You got that one and then fill in, down, up, and back. So our period is 0 to pi. We fit in one cycle, but you can see from 0 to 2 pi, we fit in 2 cycles, which is kind of cool. Okay, now we have the frequency. So frequency, I'm just going to write this one in, is the reciprocal of the period. So if we have the function y equals sine of x, that's your basic parent function for the sine function. This one has a period of 2 pi. So the frequency is going to be the reciprocal of that. 1 over 2 pi. And then what that means is that the function repeats itself. One time from 0 to 2 pi.